So this question starts off by providing us with this inequality here. I'm actually becoming a huge fan of just simply graphing these on our graphing calculator immediately and then using that visual to help answer the question. So the question goes on to say, for which of the following tables are all the values of x and their corresponding values of y solutions to the given inequality? So once you graph this, you'll see that our graph should look something like, and I'll use red for my line color here. Let's call this a negative 18 for my y-intercept. And I'm going to say that my slope obviously is positive 13. So let's go up to like a negative 5 here and a positive 1 there. So that would be my next point, my point here. So I'm going to have a line that looks something like this. And because y is greater than that, then it's going to be all values to the left of this line, right? Or above that red dashed line. So how do I use this? Well, now that I have that graph, and of course your graph will look a lot nicer because you'll have it on your Desmos calculator, we just test out every point from each answer choice. So choice A says we should have the point 321. Maybe, right? So again, this is where my rudimentary graph is not going to be all that helpful, but your graph with actual grid lines will be extremely helpful. And you'll see that A does not actually work at all. You'll see that B also doesn't work because 542 is not within the blue shaded region here. You'll see that choice C also does not work because 316 is not within the shaded region, but choice D, in fact, does work. Okay. Now, I know all that because I just worked this question out doing it in a more mathematical way. So I'll show you that way as well, but I still do strongly suggest that you get in the habit of using your graphing calculator because it really does save quite a bit of time. Now, the math way to do this would be to use the ordered pairs, right? To use the information provided in the answer choice, right? So to use a strategy called plug-in answers into our inequality and just continue to test, right? So for instance, here for choice D, we're told that when x is 3, y is 26. Well, we can test that. I can replace y with 26. I can replace x with 3. All right, and when I do that, what I see is that this becomes 26 is greater than 39 minus 18, or 26 is greater than 21, which I can confirm to be mathematically accurate. So I know that that's true. Let's try this one here. Well, this would be 52 is greater than 13 times 5 minus 18. And that will give me 52 is greater than 65 minus 18. 65 minus 18 is 47. So that is also definitely true. And lastly, I'd have 91 is greater than 13 times 8 minus 18. And you'll see that that's also accurate once you do the math there. So this is also true. So we could have done that for each of these options, right? If I didn't want to do the graphing calculator thing, we can just try each of these options in which I'm plugging in the information from the table and checking whether or not what I get from simplifying that is a true statement. Or just do what I said initially, and that is just throw this into a graphing calculator and then test these values visually versus testing them out mathematically.